Imagine this. You step into a stream of water that is far colder than your body expects. Not slightly uncomfortable, but sharply, unmistakably cold. The kind that makes your skin recoil before you've had time to form a thought about it. The reaction is immediate. Your chest tightens, your breath catches, and then suddenly it speeds up, almost out of your control. It feels as if your body has taken over, as if something older and faster than conscious thought has stepped in and pressed an internal alarm. Now here's the subtle part that most people miss. Your body is not reacting to cold water as an idea. It doesn't recognize showers, taps, or temperatures in degrees. It doesn't know you are safe in a bathroom. Instead, it operates on patterns that were shaped long before modern life existed. What it detects is a rapid loss of heat at the skin, and that pattern has historically been associated with danger. To your biology, sudden cold means one thing above all else: potential threat to survival. Think about it in a more primitive setting. If an early human fell into icy water, there would be no warm towel waiting nearby, no heater, no quick escape. The body would need to respond instantly or risk losing function. Muscles stiffen in the cold, coordination drops, and the risk of hypothermia begins almost immediately. So evolution built a system that does not hesitate. It doesn't wait for confirmation. It reacts first and asks questions later. This is why the response feels so dramatic. It is not calibrated for comfort, it is calibrated for survival. The gasp, the racing heart, the tightening of blood vessels near the skin, these are not random effects. They are part of a coordinated attempt to preserve heat and keep your core organs functioning. Blood is pulled away from the surface and redirected inward. Breathing increases to supply oxygen quickly. Your entire system shifts into a state of heightened alertness. A useful way to think about this is to imagine a smoke detector in your home. It is designed to be sensitive, sometimes even annoyingly so. It can go off when you burn toast, even though there is no real fire. But that sensitivity is intentional. Missing a real fire would be far worse than reacting to a false alarm. Your body works the same way. It would rather overreact to cold than risk underreacting when it truly matters. So when that cold water hits your skin and your body seems to panic, it's not malfunctioning. It's doing exactly what it was designed to do. The intensity of the reaction is a feature, not a flaw. It reflects millions of years of trial and error, where only the organisms that responded quickly enough survived to pass on their biology. And yet, what makes this even more interesting is that this alarm system doesn't just protect you. It sets the stage for everything that follows. Because once the body has reacted, once it has mobilized its resources and triggered its internal defenses, it doesn't simply return to normal in a quiet, uneventful way. Something else begins to happen, something less obvious but far more intriguing. The moment that cold signal is detected at your skin, a chain reaction begins that moves faster than conscious thought. Nerve endings embedded throughout your skin act like tiny sensors, constantly monitoring changes in temperature. When they detect a sudden drop, they send electrical signals through your nervous system toward the brain and spinal cord. But here's the important detail. This pathway is designed for speed, not reflection. It bypasses the slower, more thoughtful parts of your brain and activates systems that can respond immediately. At the center of this response is what we call the sympathetic nervous system. You can think of it as the body's emergency mode. It is the same system that activates when you hear a loud noise in the dark or when something unexpected happens that demands instant attention. Its job is simple: prepare you to act. Within seconds of cold exposure, this system begins to change the way your body operates. Your heart starts beating faster, pushing blood more quickly through your system. Your breathing becomes rapid and shallow, almost as if your body is trying to pull in as much oxygen as possible in a short time. Blood vessels near the surface of your skin constrict tightly, reducing heat loss and preserving warmth for your vital organs. This is why your skin may look pale or feel numb. Blood is being redirected inward, away from the surface. There is also a subtle tightening of muscles, a readiness that spreads throughout your body. Even if you are standing still, your system behaves as if movement might be required at any moment. It's a full-body preparation, not for comfort, but for survival. This entire reaction is often called the cold shock response, and the name is quite accurate. It is a shock not in the sense of injury, but in the sense of sudden system-wide activation. What's fascinating is how coordinated it is. Multiple systems, cardiovascular, respiratory, muscular, and neurological, shift together in a matter of seconds, without you needing to decide anything. Now, here's where things become less obvious. This response is not just mechanical, it is also chemical. Alongside the physical changes, your body begins releasing signaling molecules into your bloodstream. These molecules travel quickly, altering how cells behave and how different parts of your body communicate with each other. One of the primary chemicals released is norepinephrine. Its role is to increase alertness and sharpen focus. It makes your brain more attentive to the environment, more responsive to incoming information. In a dangerous situation, this would help you react quickly and make better decisions. At the same time, other substances begin to circulate. Substances that can reduce pain and change your perception of discomfort. This is important because if your body is under threat, being overwhelmed by pain would be counterproductive. You need to function, not freeze. So what you are experiencing in that moment of cold exposure is not just a sensation of temperature. It is a complete shift in your internal state. Your body has moved from a baseline mode into a heightened activated condition where perception, circulation, and chemistry are all altered. And yet, despite how intense this feels, it is still only the beginning. Because once these systems are activated, they don't simply switch off again. They interact, overlap, and create effects that are not immediately obvious. Effects that can transform an initially uncomfortable experience into something unexpectedly compelling. As this internal activation continues, the chemistry of your body begins to play a more noticeable role in shaping what you feel. Up to this point, everything might seem like a straightforward stress response. Faster breathing, increased heart rate, a sense of urgency. But underneath those obvious effects, something more subtle is happening. Your body is releasing a combination of chemicals that do not just help you survive the moment, but also change how you experience it. One of the key substances involved is norepinephrine. Earlier we mentioned that it sharpens attention, but its role goes deeper than that. It effectively turns up the signal-to-noise ratio in your brain. Irrelevant thoughts fade into the background, while sensory input becomes more vivid and immediate. This is why cold exposure can feel so mentally clearing. It's not that your thoughts have been solved or organized, it's that background chatter has been temporarily suppressed, leaving a kind of sharp, focused awareness. At the same time, your body releases endorphins. These are often described as natural painkillers, but that description doesn't fully capture their effect. Endorphins don't simply block pain. They change your relationship to it. They can make discomfort feel distant, less threatening, and sometimes even strangely manageable. In situations where the body is under stress, this allows you to keep functioning instead of becoming overwhelmed. Then there is dopamine, a chemical often associated with motivation and reward. This is where the experience begins to shift in a way that feels almost paradoxical. Why would a stressful, uncomfortable situation involve something linked to reward? The answer is not entirely straightforward, but one idea is that dopamine helps reinforce behaviors that might be beneficial for survival. If enduring a stressful condition leads to a successful outcome, such as escaping danger or adapting to a harsh environment, then marking that experience with a sense of reward could encourage similar responses in the future. What's important to understand is that these chemicals are not released in isolation. They form a kind of internal cocktail, interacting with each other in complex ways. Norepinephrine increases alertness, endorphins reduce the impact of discomfort, and dopamine adds a layer of reinforcement. Together, they create a state that is neither purely painful nor purely pleasurable, but something in between, something dynamic and shifting. This is why the experience of cold exposure can be so difficult to describe in simple terms. It doesn't fit neatly into categories like good or bad. At first, it may feel overwhelming, even unpleasant. But as these chemical systems continue to operate, the quality of the experience can change. The sharp edge of discomfort may soften, replaced by a sense of clarity or even mild euphoria. It's also worth noting that this response can vary significantly from person to person. The exact balance of these chemicals, the sensitivity of the nervous system, and prior exposure to similar stressors all play a role. For some, the experience remains mostly uncomfortable. For others, it becomes something they actively seek out. What makes this especially interesting is that nothing external has changed. The water is still cold. The environment is the same. The shift is happening entirely within your body, driven by internal chemistry. And that raises an intriguing point. The way you feel in any given moment is not just a direct result of what is happening around you, but of how your body chooses to respond to it. As these processes continue, they begin to blur the boundary between stress and reward, discomfort and relief. And in that blurred space, something unexpected can emerge. An experience that feels less like enduring cold and more like being carried through a carefully orchestrated physiological event. As this internal chemistry continues to unfold, the experience begins to shift in a way that feels almost counterintuitive. What started as sharp discomfort doesn't simply fade. It transforms. And this transformation has less to do with the cold itself and more to do with how the brain interprets change over time. The brain is not a perfect measuring device. It doesn't register experiences in absolute terms, like a thermometer reading a fixed temperature. Instead, it is constantly comparing what is happening now to what happened just a moment ago. It is sensitive to differences, to transitions, to contrast. This is a fundamental feature of how perception works. To understand this, imagine stepping into a dark room after being outside in bright sunlight. At first, you can barely see anything, but after a few minutes, shapes begin to emerge. The room hasn't changed, the light levels are the same, but your perception has adjusted. Your brain has recalibrated based on the new conditions. A similar process happens during cold exposure, but instead of light, the variable is stress. When the cold first hits, the level of stress in your system rises sharply. Your body reacts quickly, and everything feels intense. But as seconds pass, your system begins to adapt. The initial spike of alarm cannot be sustained indefinitely. Breathing starts to stabilize, the shock begins to settle, and your brain starts updating its expectations. Now here's the key moment. As your internal state moves from extreme activation toward a more controlled level, your brain interprets that shift as relief. Not because the situation has become objectively comfortable, but because it is less intense than it was before. The difference itself becomes meaningful. This is what creates the strange sense that something unpleasant is becoming pleasant. It is not that the cold has turned into warmth, or that discomfort has disappeared entirely. It is that your brain is detecting a downward slope in stress and labeling that change as positive. You can think of it like descending from a very loud environment into a quieter one. The quieter space feels peaceful, not because it is silent, but because it is quieter relative to what you just experienced. The comparison shapes the feeling. There is also another layer to this. As your breathing becomes more controlled and your body regains a sense of rhythm, you begin to feel a subtle return of control. Earlier, the reaction was automatic and overwhelming, almost as if your body had taken over. Now, you start to participate again. You adjust your breathing. You stand more steadily. You become aware that you are enduring the experience rather than being consumed by it. This shift from lack of control to regained control is psychologically significant. The brain tends to associate regained control with safety, and safety often brings with it a sense of calm or even satisfaction. So alongside the chemical changes and the contrast in stress levels, there is a cognitive layer, an interpretation that says, in effect, I am okay. All of this happens within a short span of time, often less than a minute, yet it feels like a distinct transition. The experience moves from shock to adaptation, from intensity to a kind of clarity. And because this transition is so noticeable, it can leave a strong impression, making the entire event feel more meaningful than the sum of its parts. What makes this especially intriguing is that the environment has not become easier. The water is still just as cold as it was at the beginning. The difference lies entirely in the shifting relationship between your body and the stimulus. The same input produces a different experience because the internal context has changed. In this way, the sense of relief or even enjoyment that can follow cold exposure is not something added from the outside. It emerges from the dynamics of your own perception, from the way your brain tracks change, updates expectations, and interprets the movement from one state to another. As this experience continues, another subtle factor begins to shape how it feels, your sense of choice. Up until now, everything we've described could happen whether you intended it or not. The cold hits, your body reacts, chemicals are released, and perception shifts. But there is a critical difference between something happening to you and something you deliberately step into. If you slip unexpectedly into freezing water, the reaction is almost entirely negative. Panic dominates. The rapid breathing can become uncontrollable, even dangerous. Your thoughts narrow, not into focus but into confusion. In that situation, your brain classifies the event as a threat with no clear resolution. The same physiological systems are activated, but the interpretation is very different. Now compare that to stepping into a cold shower by choice. The physical stimulus is similar, but your brain enters the situation with prior knowledge. It has a model of what is about to happen. It expects the shock, even if it cannot fully predict the intensity. That expectation changes how the incoming signals are processed. This difference can be understood as the gap between prediction and surprise. When something unexpected happens, the brain struggles to interpret it quickly. It treats the event as potentially dangerous because it lacks context. But when something is expected, even if it is uncomfortable, the brain has already prepared a framework for understanding it. The experience is still intense, but it is not as chaotic. There is also an important shift in how control is perceived. When you choose to enter cold water, you retain the option to leave. That option may not be exercised, but its existence matters. It creates a background sense of agency. You are not trapped, you are participating. This changes the emotional tone of the experience. From a biological perspective, voluntary stress often leads to a different pattern of response than involuntary stress. The same chemicals may be released, but the balance can shift. Instead of overwhelming panic, there is a more structured activation. The system is engaged, but not entirely out of control. This allows the body to operate more efficiently under the same conditions. You can think of it like lifting a heavy weight. If someone suddenly drops that weight into your hands without warning, it might injure you. Your muscles are unprepared, your posture is wrong, and the force is chaotic. But if you deliberately pick up the same weight, your body organizes itself. Muscles tighten in the right sequence, your stance adjusts, and the load becomes manageable. The physical demand is similar, but the outcome is completely different because of preparation and control. Cold exposure works in a comparable way. The stimulus is not inherently beneficial or harmful. It depends on the context in which it is experienced. When approached voluntarily, it becomes a kind of controlled stress, something the body can engage with rather than simply endure. This also influences how the experience is remembered. The brain tends to store events not just based on their intensity, but on how they end and how much control was involved. If an experience begins with discomfort, but ends with a sense of mastery or stability, it is more likely to be remembered positively. Over time, this can change your relationship with the stimulus itself. What's fascinating is that nothing about the cold has changed. The water does not become warmer, the physical properties remain the same, yet the meaning of the experience shifts depending on your role in it. Whether you are a passive recipient or an active participant determines how your brain categorizes the event, and this reveals something deeper about how the body and mind interact. The signals coming from the outside world are only part of the story. Equally important is the framework your brain uses to interpret those signals, the expectations, the sense of control, and the context you bring into the moment. There is a temptation at this point to draw a simple conclusion that if something produces a feeling of clarity or even mild euphoria, then it must be good for you in a straightforward way. But biology is rarely that simple. The systems involved in cold exposure were not designed to improve your mood or give you a pleasant experience. They were shaped to solve a very specific problem: how to keep an organism functioning under potentially dangerous conditions. When your body releases substances like norepinephrine, endorphins, and dopamine, it is not trying to reward you in the way we usually think about reward. It is adjusting your internal state so that you can continue to operate despite stress. Increased alertness helps you respond quickly. Reduced perception of pain allows you to keep moving. The sense of reinforcement may encourage behaviors that, in certain environments, improve your chances of survival. The important detail is that these effects are context-dependent. In a natural setting, sudden cold would often be paired with a real challenge: escaping water, finding shelter, generating heat. The chemical response would support those actions. In a modern setting, where the cold exposure is brief and controlled, those same mechanisms are activated without the larger survival problem attached. What you experience is the internal response, separated from its original purpose. This separation can create the impression that the experience itself is inherently beneficial, as if the cold were delivering something positive into your body. But in reality, it is your body generating a response that happens to feel a certain way under these conditions. The feeling is real, but its meaning is not as straightforward as it might seem. There is also a limit to how much stress the system can handle. The same mechanisms that allow you to adapt to short bursts of cold can become harmful if pushed too far. Prolonged exposure can overwhelm the body's ability to maintain core temperature. Breathing patterns can become unstable, coordination can decline, and the risk of serious consequences increases. The line between controlled stress and uncontrolled stress is not always obvious, but it is very real. This highlights an important principle. The body operates within ranges. Many systems are beneficial within certain limits and harmful outside them. Temperature, pressure, chemical levels. All of these variables have zones where the body can function effectively. Cold exposure fits into this pattern. Brief, controlled exposure can be tolerated and even adapted to, while extreme or prolonged exposure can exceed the system's capacity. Another point that is often overlooked is individual variation. Not everyone responds to cold in the same way. Differences in body composition, circulation, prior exposure, and even psychological factors can influence the experience. Some people may find the transition from discomfort to clarity more noticeable, while others may primarily feel the stress without the same shift in perception. These differences do not mean that one response is correct and another is not. They reflect the complexity of biological systems interacting with personal history. What makes this topic particularly challenging to explain is that the language we use tends to simplify things too much. Words like good, bad, healthy, or harmful suggest clear categories, but the underlying reality is more nuanced. The body is constantly balancing competing demands, adjusting to changing conditions, and operating within constraints that are not always visible. So when you step into cold water and feel that sequence of shock, adaptation, and eventual clarity, you are not experiencing something designed for comfort or enjoyment. You are witnessing a set of survival mechanisms being activated in an environment that no longer matches the conditions in which they evolved. The result can feel unusual, even paradoxical, because the system is doing its original job in a context where its purpose is no longer obvious. And that is what makes the experience so intriguing. It reveals that the sensations we interpret as pleasure, relief, or even meaning are often byproducts of deeper processes. Processes that were never intended to produce those experiences in isolation, but which do so under the right conditions. As you try to make sense of all this, you may notice a deeper difficulty that goes beyond biology itself. It's not just that the body is complex, it's that our usual way of thinking about experiences doesn't quite fit what is happening here. We tend to divide things into clear categories: pain or pleasure, good or bad, stress or relaxation. But what you are observing during cold exposure doesn't stay inside those boundaries. It moves between them, sometimes occupying both at once. This creates a kind of conceptual tension. At the beginning, the experience feels undeniably uncomfortable, even threatening. Your body reacts strongly, your breathing becomes erratic, and there is a clear sense that something is wrong. But within a short time, that same experience can begin to feel controlled, even stabilizing. In some cases, people describe a sense of clarity or calm emerging from what initially felt chaotic. The difficulty is that our language is not well equipped to describe transitions like this. We tend to label the entire experience based on how it feels at its peak or at its end, rather than acknowledging that it is a process unfolding over time. But the meaning of the experience is not located at a single point. It is in the movement between states. Part of the confusion also comes from how the brain constructs experience. It doesn't simply receive signals and present them to you in a neutral way. It actively interprets those signals, combining them with expectations, past experiences, and internal models of the world. This means that what you feel is not just a direct result of the cold itself, but of how your brain organizes and explains that sensation. For example, if you approach cold exposure with fear or uncertainty, the brain may amplify the threat aspect of the experience. The same physical stimulus can feel more overwhelming, more difficult to manage. On the other hand, if you approach it with familiarity or curiosity, the brain may emphasize the aspects that signal control and adaptation. The cold has not changed, but the interpretation has. This is not simply a psychological effect layered on top of a physical one. It is part of the same system. The brain and body are not separate components. They are continuously influencing each other. The signals from your skin affect your brain, and the expectations in your brain affect how those signals are processed. Another layer of complexity comes from the fact that multiple systems are operating at the same time, sometimes with competing priorities. One part of your body is trying to conserve heat by restricting blood flow to the skin. Another part is increasing alertness and readiness for action. Yet another is releasing chemicals that reduce discomfort and encourage persistence. These processes do not always align neatly, and the result is an experience that can feel mixed or even contradictory. This is why it is so difficult to give a simple explanation for why cold exposure can feel good. The feeling is not coming from a single source. It is the result of several overlapping processes, each contributing something different. When these processes interact, they can produce outcomes that are not obvious from any one component alone. What you are encountering, in a very direct way, is the layered nature of perception. There's the raw sensory input, the cold on your skin. There is the immediate physiological response, the changes in breathing, heart rate, and circulation. There is the chemical modulation, the release of substances that alter how you feel. And there is the interpretive layer, the way your brain organizes all of this into a coherent experience. These layers are usually hidden from view because they operate seamlessly. You simply feel what you feel, without noticing how many steps are involved in creating that feeling. But in situations like cold exposure, the transitions are sharp enough that you can begin to sense the structure underneath. You can feel the shift from one state to another, and in doing so, you catch a glimpse of how the system works. And that glimpse can be unsettling because it challenges the assumption that your experiences are simple reflections of the world. Instead, it suggests that what you feel is constructed, moment by moment, from a combination of signals, processes, and interpretations that are constantly interacting beneath the surface. If we keep following this line of thought, we reach something even more unsettling, but also more honest about how you actually exist in the world. Because at this point, it becomes difficult to say that you are simply feeling cold water. What you are actually experiencing is a layered reconstruction of reality inside your nervous system. The cold water itself is just a physical condition. Molecules moving faster or slower, transferring heat away from your skin. But everything you experience from it, shock, discomfort, alertness, relief, clarity, even pleasure in some cases, is something built internally. This is not a poetic idea. It is a biological necessity. Your brain does not have direct access to the outside world. It has no sensors that touch reality itself. It only receives electrical signals from nerves, and those signals are already simplified versions of what happened at the surface of your body. From there, the brain does something extraordinary. It constructs a model. It tries to guess what is happening out there, based on incomplete data, and it updates that model continuously. So when cold water hits your skin, what enters your nervous system is not cold as a complete object. It is a pattern of changing signals. Temperature drop, pressure, sudden exposure, spatial distribution across skin receptors. The brain then interprets that pattern and assigns meaning to it. This is where things become deeply interesting. The meaning is not fixed. The same physical input can be classified as harmless, uncomfortable, threatening, or even rewarding depending on context. That classification is not in the water. It is in the interpretation. Think about a simple example. A loud sound in a movie theater might make you jump, but the same sound at a concert might excite you. The physics of the sound waves are identical. What changes is the context your brain assigns to them. Cold water behaves in a similar way, except the interpretation runs deeper because it involves survival systems that evolved long before modern environments existed. Your brain is constantly asking questions like, is this dangerous? Do I need to escape? Can I adapt to this? What is the likely outcome if I stay here? But these questions are not conscious in the usual sense. They are computed automatically beneath awareness. And here is where the strange part appears, because once the brain determines that a situation is intense but survivable, it can shift from pure alarm into a different mode. Adaptation. In that mode, the same signals that initially triggered panic begin to be reinterpreted. The stress response is still active, but it is now being regulated. The system is no longer escalating, it is stabilizing. And this stabilization is not neutral, it is felt. You experience it as a shift in state, a transition from chaos toward order. From overwhelming input toward manageable intensity, from uncertainty toward control. But again, nothing outside you has changed. The water is not less cold. The environment is identical. What has changed is the internal model, how your brain is predicting and explaining what is happening. This leads to a crucial realization. Perception is not a recording device. It is a controlled hallucination that is constantly being corrected by incoming data. The word hallucination here is not meant to imply error. It means construction. Your brain is actively generating a version of reality that is useful for survival, not necessarily identical to the raw physical world. Cold exposure makes this visible because it pushes the system hard enough that you can feel the construction process itself. You can sense the shift from shock to adaptation, from instability to coherence. And once you notice this, it becomes difficult to return to the idea that experience is simple or direct, because what you are really encountering is not just cold water. It is your mind negotiating with reality in real time, trying to turn raw physical signals into something that can be lived inside. If we take everything we've explored so far and step back just a little, a deeper question begins to appear. That is no longer just about cold water, or even about the body's chemistry, but about what it actually means to experience anything at all. Because at this point, cold exposure is no longer just a physical event. It has become a demonstration of something much more general. The fact that your relationship with the world is always mediated, always interpreted, always constructed. You never encounter reality directly. You encounter a version of it that your nervous system has assembled for you. And that version is not static. It changes depending on context, expectation, memory, and internal state. This is why the same stimulus can produce such different outcomes. Cold water can feel like shock or challenge or clarity or even something close to pleasure. But none of those labels belong to the water itself. They belong to the way your brain organizes the incoming signals. At first, this might sound abstract, but it becomes clearer if you consider how fragile perception actually is. A slight change in breathing can alter your sense of panic. A different expectation can change whether a sensation feels threatening or manageable. Even a small shift in attention can transform what stands out and what fades into the background. Nothing external needs to change for the experience to change. This is a crucial point, because it reveals that what you call reality is not a fixed picture you passively receive. It is an active process that is continuously being generated. And that process is constrained by biology. Your nervous system evolved not to show you the world as it is in some absolute sense, but to keep you alive long enough to reproduce. That is a very different goal. Survival does not require perfect accuracy. It requires useful predictions. So instead of constructing a perfect model of reality, your brain constructs a functional one. It highlights what matters for action and suppresses what does not. Cold water, in that sense, is not just temperature. It is a prediction problem. Is this a threat? Is this manageable? Do I need to escape? Or can I remain and adapt? These questions are not answered consciously. They are resolved through layers of neural computation that happen beneath awareness. What you feel is the outcome of those computations, not the computations themselves. And this leads to something even more subtle, because if your experience is the result of a constructed model, then what you call you is also part of that construction. The sense of being a stable observer, someone who experiences cold, warmth, fear, or relief, is itself a product of the same system that is interpreting the signals. In other words, there is no separate you standing outside the process watching it happen. There is only the process, organizing itself into a coherent experience of being someone. Cold exposure makes this unusually noticeable because it disrupts the usual balance. It forces the system into rapid adjustment. It compresses time. It amplifies internal signals. And in doing so, it briefly reveals the machinery that is normally invisible. You do not just feel cold. You feel the transition between states of interpretation. And that transition exposes something important. Stability is not the default condition of experience. It is something actively maintained. The brain is constantly working to keep perception coherent, to prevent raw signals from becoming overwhelming noise. When that system is stressed, you can feel the effort behind it. So what seems like a simple experience, standing under cold water, turns out to be a window into something far more fundamental. Not just how the body reacts to temperature, but how a physical system can generate a continuous inner world from fragments of sensory input. And once you see that clearly, it becomes difficult to think of experience as something obvious again. Now we arrive at a place where the question itself begins to change. Because if everything we've described is true, that your experience of cold water is constructed, that your brain is constantly interpreting signals, that meaning emerges from prediction and adjustment, then the original question, why does cold water feel like a drug, starts to dissolve. It assumes there is a clear boundary between external substance and internal effect. But what we've seen is that the effect is not something added from outside. It is something generated inside by systems that were already there, waiting for input. Cold water does not contain reward. It does not contain pain relief. It does not contain clarity or euphoria. Those are not properties of water. They are properties of a nervous system responding to a very specific kind of challenge. And that leads to a deeper realization. What we call experience is not a window into the world. It is a control system. It is constantly trying to do something extremely difficult. Take incomplete noisy signals from the body and environment and turn them into a coherent model that supports survival and action. When that system is working smoothly, you don't notice it. You simply feel normal. The world feels stable, your body feels predictable, and your attention flows without interruption. But when something like cold water interrupts that stability, you get a rare opportunity to see the system in motion. At first, the model breaks. The body reacts faster than interpretation can keep up. There is shock, urgency, and confusion. Then gradually, the system catches up. It reorganizes. It updates its predictions. It shifts from alarm to adaptation. And in that shift, you feel something happening not in the water, but in the relationship between your body and the water. That something is what we often describe as sensation. But sensation is not passive. It is an active construction. This is why the same physical stimulus can produce such different subjective worlds. One person experiences cold water as unbearable stress. Another experiences it as clarity. A third experiences something in between. The physics is identical. The construction is not. And this is where the philosophical weight begins to emerge. If your experience is constructed, then the boundary between real and felt becomes less clear than we usually assume. The cold is real in the sense that molecules are transferring energy. But the meaning of that cold, the panic, the relief, the focus, is not located in the molecules. It is located in the interpretation. And interpretation is not optional. It is what your brain does continuously, whether you are aware of it or not. Even the sense that there is a you experiencing all of this is part of that same construction. A stable identity is something the brain generates to keep experience organized over time. Without it, there would be no continuity, only fragments of sensation without coherence. So when you step out of a cold shower and feel calm or alert or strangely refreshed, what you are really noticing is not a transformation in the water or even in your body alone. You are noticing the successful completion of a complex internal adjustment process. The system was challenged, it responded, and then it stabilized. And that stabilization is felt as experience. From this perspective, cold water is not a drug. It is not a substance producing effects inside you. It is a trigger that reveals how effects are always already being produced, continuously, silently, by the machinery of perception itself. And that leads to a final, quieter conclusion. You are not standing inside reality, observing it as something separate. You are part of a system that is continuously generating what reality feels like from moment to moment. Cold water just makes that fact briefly visible,